Section 1.6, page 1. We're talking about limits that involve infinity. And according to Merriam-Webster Dictionary, the definition of infinity, written as the symbol that appears to be similar to an 8 on its side, is the limit of a value of a function or variable when it tends to become numerically larger than any pre-assigned finite number, an indefinitely great amount, unlimited extent, or boundless. Although we know we often think of infinity as an idea, not an actual number. Today we're going to look at infinity two different ways. First as the output of a function and then as the input of a function, and we'll use that throughout this section. So let's go ahead and start talking about infinity as the output of a function. Consider taking the limit of some function as x tends to whatever number, but the result is positive or negative infinity. Now, although we state that the limit does not exist, there is information we can use to describe the behavior of the function at that point. There is no limit, but what's happening there? So at first I'm asked to find the limit as x tends to pi. I've got this number line here, and you can see pi has a dashed line vertically going through it because the graph never obtains a value at pi. So over here at pi, we can see what's happening. Because both sides of the function are headed down, assuming that positive infinity is vertically at the top and vertically negative infinity is at the bottom, this function did not have a limit, but it does tend towards negative infinity. So obviously your directions may say find the limit and state infinity or negative infinity if more appropriate. Now this particular question only asked me to find 3 pi, which I can see on the graph, but only from the left because of the negative exponent. So when I just look to the left of this line, I can see my graph is headed up towards positive infinity. Hopefully you remember, these are also called vertical asymptotes. The function does not exist at these points, and these points are where the x values are pi and 3 pi. Keep in mind, a function cannot and will never cross a vertical asymptote. As this function continues this way, it's going to go up here forever. It's never going to go just a little over that line. So instead of output, what if infinity was the input? So I'm plugging in positive or negative infinity, remembering that for our number line here, negative infinity is on the left and positive infinity is on the right. So if I'm asked to find the function's limit at negative infinity, I'm thinking what's happening as this function keeps heading this direction? Well, I can see it looks like it continues to grow and grow and grow, so it's headed up to some large infinite number. But when I'm asked to find infinity as the graph is going in the direction of positive infinity, it looks like it's flattening out at x equals 3. You can see the 3 a little better as I zoom in. So I've got my horizontal asymptotes. Keep in mind that 3 comes from a y value, from my y-axis. So I'm going to say y equals. Notice we don't say y equals infinity is a horizontal asymptote because we're only using actual numbers. It's important to understand the difference between horizontal and vertical in the fact that a horizontal asymptote can be crossed. Well, not here, right? It's flattening out here, but there's other spots that may be above 3 and below 3, and even obtaining 3 at various other regions.